Welcome to a lesson with Dr. Powell. Let's take a look at more logarithms intuitively and how we can kind of think of these, and especially when we might see something that pops up in an equation. One very nice thing to use is kind of this exponent idea of exponents inside of a logarithm. Like if we had log base 2 of h squared, so 2 to what power is h squared is what this is. Let's just think of this in pieces. So the exponent that we need to put over 2 to make 8 is 3, right? But then we would double that because of this. See, right here we're doubling the amount of factors that we have. See, whenever you square something, you're doubling the factors that you have. So you have 2 times 2 times 2, right? And you're going to be doubling that. Okay, now you're going to have 6. All right, so this is 2 cubed and squared. So this is going to be, so of course it's going to be 6. We can think of this as being log base 2 of 3, and then we're doubling that. So the exponent right here, it multiplies to the exponent that makes that guy, okay? Now we're going to use this in another situation. What if we had something like 3 to the x is equal to 5? Now, x is equal to the exponent that makes 5 over 3. We could write that simply as x is equal to log base 3 of 5, right? But sometimes we don't want to write this in with this operator, with this log base 3 operator. Sometimes we want to use a different operator. A very common operator to use, especially for calculus, is ln. What is ln? ln is the same thing as log base e, where e is some fancy number, 2.7, and it keeps on going on and on. Now, this particular number is nice because well, at least one thing it does is in the computations in calculus, it gets rid of a lot of nasty constants when we are working with this base. So our results look nicer. So what if we want to write x in terms of this guy right here? So we're going to focus on this equation right here, 3 to the x is equal to 5, and we're going to put both sides of this equation inside this operator. Let's think what this operator does. It says how many ideas of multiplication by e is this? How many ideas of multiplication by e is that? Let's write the operator down. So ln of 3 to the x is equal to ln of 5. So e to what power is that? How many ideas of multiplication by e do we get that? How many ideas of multiplication by e gives you 5? Well, this exponent idea allows us to think about this x as just being multiplied to the number of e's that we need in an expression to multiply together to make 3. So e to the what power is 3 times x is the same thing as this. This guy just naturally meanders down. So that's going to be equal to ln of 5. Well, that tells us what x is. X is ln of 5 divided by ln of 3. So we see two nice ideas here. One is how do we bring exponents down in an equation to solve for something? The other idea is how do you rewrite something like this, log base 3 of something, in terms of another base? In particular, with base e, which we'll write ln. That's kind of shorthand for log base e. That's just what's normally written. So we saw that this is equal to ln of 5 over ln of 3. Notice, if you want some kind of mnemonic, this 3 is down below, this 5, which is higher, is up above, and you have a fraction of two things, ln of 5 over ln of 3. So, nice change of base. This can become important, especially when we have something like, what if we have like log base 3 of x, not 5, but just kind of something like x? How can we rewrite that in terms of ln? Well, simply we just replace the log base 3 with ln itself, ln of x, but the trade-off is we have to divide, and we divide by a constant. What constant do we divide by? We're going to divide by the ln of 3. So notice the function. If we had this, so if we had some function like f of x is equal to log base 3 of x, This function right here can be rewritten like this. It is simply the same thing as a function that's equal to ln of x, but then you just divide by a constant. The constant ln of 3. ln of 3 is not a variable, it's a constant. Why? Because we've plugged a number into a function and gotten out a specific number. So this is a constant. So we have a variable function here divided by a constant, and that's going to be equal to this function. Nice relationship between these two functions. They're just constant multiples of each other. In fact, all log-based functions, no matter what base you're working with, are all constant multiples of each other in such a fashion. Thanks for watching.